Welcome back. So here is another topic, compound interest. Let's continue with that. We did simple interest in the last lesson. So this lesson, we're going to deal with compound interest. So what was the definition of compound interest? Just a reminder, amount on the initial invested or loan and all the accumulated interest from the previous period. That's what compound interest definition is. So let's look at this example so that I can drive the formula for you, which is instead of just giving you the formula, I just want to have a little bit of understanding of how we end up getting the formula. And it's very intuitive actually. So suppose you made a long-term investment of $1,000 at a fixed rate of 5% compounded annually. So let's calculate the value of investment at the end of each year. So it's very straightforward. So the first year, the compound interest and the simple interest, they're the same. So year one is the same calculation as simple interest because you're just adding the interest amount to the original amount and you're done. I want to make sure to go over this way of writing so that you're aware what is happening. We use that for the simple interest as well. But let's just start off with this one, which is I just want to explain that. So initial investment is 1,000, then you have to add the interest amount, which is 5% compounded annually, to the initial amount that you invested. But how do you calculate the interest amount? Well, it's 5% of the $1,000. So that's what you have to add that to the original amount. Now, if you factor 1,000 out of this expression, you get 1 plus whatever is left is on the second term would be 0.05, which this is 1.05. And this is where you get this value right here. So I just want to make sure that you're not confused when you see the formula, but that's what you get. So the second year, now that we know that the first year you have 1.05, well, the second year you will have 1.05, and this time you have to multiply it. Okay, and because you're actually, again, using the interest rate, but now you're using it on not the $1,000, but you're using it on this amount is now your new amount for year two. Okay, and that what makes compound interest very powerful in terms of growth. So now notice what is happening, that we are using exponent laws to, so this is now power of 2 because there are two 105. You see that? There's one in here, one in there. So to make it more compact, we write it at 1,000 times 1.05 to the power of 2. Now, notice this 2 here, notice that 2 there. And then notice this 3 here. The same thing applies again. You start with the principal amount, which is 1,000. You have 105, 105, 105, and then this in a compact form, 1,000 times 105 to the power of 3. And here is the final compact form of the formula, and that is for any year n, this will end up being, instead of t, should have said n, is 1,000 times 1.05 to the power of n. There should have been t in here and t there, or n here, n there. All right, so now that we have that, let's put them all together. So this is the formula for the accumulated amount based on the initial amount, and it becomes a kind of a, this is actually exponential equation for pre-calculus 12. This is part of the logarithmic and exponential function and equation unit. Okay, now that we have this, let's put them all together, and I put a note in here so that you see how the formula will work. All right, so the formula that will work, okay, and then you have to pay attention to a couple of things. If the compounding period is less than a year, then semi-annually, quarterly, monthly, weekly, daily, hourly, whatever that is, then the rate needs to be divided by that number of compounding period. So this is where n is. This n represents this compounding period. And t is the length of time that is needed to be multiplied by that number. All right. So in this case, for example, if n is a number of compounding period, if it's compounding annually, that means once a year, so n will be 1. Semi-annually, n is 2. Quarterly, n is every 3 months, that means 4. Monthly, n is 12. Weekly, n is 52, and so forth, 36, 365 for daily, and hourly, of course, you have to do the hourly. And that's what you would do for this formula. You plug it in and you will get it. So let's do an example here. What is the value of the initial investment of 1,000 at 7% compounded monthly after 10 years? So we have P, we have R is equal to 0.07, and it is N is monthly, which is 12, and T is 10 years. All right, we're going to plug numbers in. So P is 1,000. We are using this formula right there, times 1 plus R, 0.07, divided by N is 12, to the power of N times T. N times T, that's the exponent right there. So that would be 10, actually 12 times 10. And then we're going to take out our calculators and do the math on that one. And I got $2,009.66. That is the accumulated amount of that initial investment of 10,000 at 7% compounded monthly after 10 years. All right, so pay attention to this formula and how you put in the variables, the values for each variable is very crucial, and you don't make a mistake. Now remember, this is the exponent. You have to make sure you're using exponent key on your calculator. Here's another question about compound interest. That's an interesting question. So how long will it take for an investment to double at 7.5% compounded annually? And I put down here the compound interest formula just in case you've forgotten it. But let's see what we have. We don't have it, seemingly, we don't have any information except the compounded annually and the interest rate, right? But we have few other information. We have this double thing here, and it says an initial investment, so we can use anything that we want. Let's suppose our initial investment, let's call that P. So let's P be $1, just to make it simple. Well, what would be the accumulated amount? A. Well, it says double, so there should be $2. That's what it will be. And we know that the rate is 7.5%, which is equal to 0.075, and it's compounded annually. And we want to know how long will it take. That means T, and because it says annually, that means we do know that N is equal to 1. Oh, perfect. Now let's go ahead and plug numbers in and let's see what we get. So we have 2 equals to 1, which is for P, then 1 plus 0.075 over 1. I didn't have to do that, but I'm going to write it up anyways. And then to the power of 1 times T, which is T. All right, now let's do some mathematical gymnastics here to simplify the bracket and what we have. So that would be 1.075 to the power of T. Okay, if you are working at pre-calculus 12 or algebra 2, then you have to use logarithmic law to solve this exponential equation. Okay, there's no other way to do this. The other way, as in not getting the exact value, is you use table of values. What does that mean? You choose some random number that are reasonable and you plug it in, and let's see what you will end up getting. Now, I suggest you start, because it says doubling and the interest rate is under 10%, do that. Let's suppose T is 3. Is 2 equals to the other side? How close to the other side will it get? So basically 1.075 to the power of 3. Are these two equal to each other? Let's double check. When you plug it in, you get 1.2423 approximately, so not even close to 2. We want to get as close as we can possibly get to 2, okay? So 3 can't work. All right, do t equal to 6 and then do the math again, and let's see what you will get. You should get 1.5433. Again, not even close to 2. Let's go to 9. Let's punch in 9. With 9, I get 1.917. Oh, it's getting closer to 2. So I would go 1 year. So do 10. And when you do this, you notice that the answer you will get is actually goes over by a little bit. So you can actually play around between 9 and 10, and since this is closer to 2, so I would go to 9.9. We get 2.046. Now it's coming closer to 2, and then you choose 9.6, and then we can stop right after that, 9.6. You can try 9.8, 9.7, and keep coming down, but then you notice that T 9.6 will give you 2.00226, which is very close to 2. That means that it will take 9.6 years for this investment at 7.5% compounded annually to double. Now, and this leads me to tell you about this law or the rule of 72, which is a ballpark rule really for in finance. What it means is this: in order for you to double your investment, you take the 72, you divide it by the 7.5%. You don't use the percent in the calculation, you just use 7.5 only. The value that you get out of this, you get 9.6. Okay, and that's the approximation, but what it is a very good approximation. So this rule of 72 is a foundational rule for investment. The rule of 72, I want to make sure, rule of 72 is 72 divided by interest rate, but without a percentage. In this case would be the rate, but like for example, in the top example will be 72 divided by 7.5. It's not a percentage. You don't use the percent in the calculation. You just use 7.5 only. This is why you get 9.6. Okay, make sure you do that. So when you are on the receiving end of it, you want compounding interest. When you are at giving end of it, you want to give as a loan. You want to give the interest as a simple interest because you don't want to get charged more. So this is the lesson for the compound interest. I hope you found this useful. If you did, consider subscribing, like, comment below, and tell me what else I can share with you so that it can level up your math. All right, until next time, keep at it.